Hello, Mrs. Burkhart here. Welcome to the Unit 1 review video. And this video is to help you learn how to work the problems on the review in your OMHS. So pull up your Unit 1 review. You can work with me or you can get started in your work and work on your own first and then double check in with me if your answer is correct. Okay, so let's get started here. So the first one is to write an inequality that represents the problem. The problem is the sum of three consecutive odd integers is at least 105. So we know that the keywords for sum is adding. Okay, I'm just going to go ahead and kind of underline that. The sum, we know that we are adding, and the word is at least has a symbol greater than or equal to. But we need to figure out first our expression for that. So there are three consecutive odd integers. So when we're talking about odd numbers are always two apart. So let's call the first odd as x. All right. And then this is our first odd. And since they are two numbers apart, meaning you're adding 2 from the first one, so the second odd would be x plus 2. Okay, that's your second odd. And then your third odd would be x plus 4. So those are our expressions for the three consecutive odd integers. Now that we have those information, so the sum means when you're adding. So when you're adding these three numbers, so that means we're going to take x, okay, which is the first odd, plus the second odd, which is x plus 2, okay, plus the third odd, which is x plus 4. The result is at least, so meaning it's greater than or equal to 105. All right, so that's our expression for the first one. Alright, so for the second one, it says what? Inequality that represents a statement. So the length of a rectangle is 3 times its width, given the area of the rectangle is less than 300 square meters. So I always like to draw a picture here. So let's say we have a triangle, alright? So this side right here is our width, which is represented by a W. And this side right here is our length, which is represented by a cursive L, so that's an L right there. And on this statement, the length of a rectangle is 3 times its width. So that means the length right here is equal to 3W. Alright, now another information that is given in the statement is the area of the rectangle. So by the formula, okay, we know the formula for getting the area of a rectangle is taking the length times the width. But it says right here the area, meaning if we're taking the length times the width, it is less than. Okay, it's not equal to, but it is less than, smaller than 300 square meters. So what I'm going to do right here, since the statement says the area, this area right here, meaning if we're taking the length is given as 3 times its width, which is 3W. So we're going to replace that length with 3W times, okay, the width. Okay, so if we're multiplying those two, okay, we will get the area. But the area is less than 300. So it's not equal to 300, but smaller than 300. So that is our inequality representation for the statement. Alright, so moving on to number 3, okay, we have this statement that says Pat is twice the height of his sister. The difference of their height is at least 30 inches. What is the minimum height Pat's sister can be? So we are going to break this one into chunks, into sentences. statements because there's a lot of information that is that can be found on this statement. So the first statement is the first sentence that is stating that Pat is twice the height of his sister. So I'm going to underline that first. Okay, so Pat is twice the height of his sister. Wow, that's really nice line right there. I'm so sorry. Okay, let me fix that. Okay, so Pat is twice the height of his sister. So, but the problem is we really don't know what's the exact height of his sister. So what I would do here is we are going to represent x, okay, equal to height of Pat's sister, okay? Because we don't really know, okay? Remember, whatever is the unknown in the problem, okay, we are going to represent it with a variable. Now that we represent the height of Pat's sister as a variable x, now according to the problem, Pat is twice the height of his sister. So that means 2 times x, which is represented by the height of Pat's sister, double that is the height of Pat. Okay, the height of Pat. All right, now that we represented the first statement, okay, as x, which is the height of Pat's sister, and 2x would be the height of Pat. Now let's move on to the next statement. So the next statement says that the difference of their heights, okay, is at least 30 inches. So difference right here is subtraction, okay? That is minus. Now, I would say that the height of Pat, so Pat is taller than his sister, okay? Because of the 2 right here, you're doubling the height of Pat's sister. So that means I can assure that Pat is taller than his sister. So, but it says right here the difference, so that means I am going to take the height of Pat, which is 2x, since it is different, so we are going to subtract the height of Pat's sister, okay? Is at least means it's greater than or equal to, okay, 30. So the difference of these heights is greater than or equal to 30. Now, what we can do right here is we are going to solve, just like an inequation, we are going to solve what is the value of our x. But on the left side of our inequality, they can be simplified because they are like terms. So 2x minus x, that would give us 1x, or it would be just x, okay? 1x or just x, greater than or equal to 30. So I'm going to put right here, or I'll just put x greater than or equal to 30. Okay, now since this x right here represents the height of Pat's sister, we can actually answer the question, because the question is what is the minimum height Pat's sister can be. So Pat's sister can be, okay, can be 30 inches. So that x right here, okay, is Pat's sister's height, can be 30 or higher than 30. But the minimum height is 30 inches. So I would say that the minimum height of Pat's sister okay, can be 30 inches. All right. All right, for number 4, we have here an inequality x over 5 less than negative 20. All right, to solve this inequality, the first thing you need to figure out is where is a variable, okay? So just like you're solving an equation, you are going to solve what is the value of our x. And our x right here is divided by 5. So whatever this value of your x divided by 5 is less than, meaning it's smaller than negative 20. It cannot be equal to negative 20, but it has to be smaller than negative 20. So to get the value of our x, okay, we are going to use the inverse operation. So that means I am going to multiply that with that 5, because the inverse of dividing by 5 is multiplying it by 5. So I'm going to multiply that with 5. So what I do on one side, I also have to do it on the other side. So that means I also have to multiply the negative 20 times 5. All right, now this 2 cancels out, because when you do an inverse operation, that cancels out the number. So what's left on the left side is just your x, all right? And then you are going to bring down the inequality symbol and multiply negative 20 times 5. So that makes it a negative 100. So the solution to the inequality is x less than negative 100. So that means if you are going to pick any number less than negative 100 but not equal to negative 100 and replace that value to your variable x, then the inequality will hold true. All right, so let's move on to number 5. So for number 5, we are going to solve the inequality 3t plus 6 less than or equal to negative 30. So again, just like solving for an equation, we are going to look at where is our variable. So our variable right here is on the left side, which is the letter t. And if you have that number in front of it, so that means you have 3 times t plus 6 less than or equal to negative 30. Now, we've talked about order of operation before, but since we are looking for the value of t multiplied by 3 adding 6, is smaller than or equal to negative 30, and to solve for that t, we have to do the order of operation backwards. So that means instead of doing the inverse of multiplying or dividing first, we are going to do the inverse of adding 6 first. So we have to get rid of that adding 6 by getting its inverse. So the inverse, or meaning the opposite of adding 6, is subtracting 6. So what you do on one side, you have to do it on the other side. So positive 6 and a negative 6, okay, if you remember your opposites, this cancels out each other. Positive 6 minus 6 will give you 0. So what's left on the left side would be just 3t. So I'm going to put that one down here. Okay, copy it down. Okay, and I'm going to copy down the symbol less than or equal to. And what happens to our negative 30 minus 6 when you have two negatives? Okay, it's like you owe $30 plus you owe $6, so in total you owe $36. So that is a negative 36. All right, now our answer does not end there yet because we have to find the value of t. So 3 times t, the opposite of multiplying 3 to t is dividing it by 3 to isolate the t, or to isolate the variable by itself. Isolate means to get the variable by itself. So what you do on one side, you have to do it on the other side. So 3 divided by 3, that cancels out, meaning it's just 1t or just t, okay? Copy down the symbol, okay, less than or equal to, and 3 goes into 36 12 times, but you have to keep that negative sign, just like your multiplication rule of integers. When you have negative times the positives, you get a negative. Same thing with dividing. When you are dividing a negative number by a positive number, so you still have to keep that negative sign. So it would be negative 12. So the solution right here for our t is less than or equal to negative 12. Now you're going to pick any variable that is smaller than or equal to negative 12, and you're going to replace that with your variable to t. It will hold the inequality true. Alright, for number 6, we have the sum of a whole number n, and negative 7 is no greater than negative 35. What is the greatest value of n that makes this statement true? So the problem is saying that if you have a whole number n and negative 7, or when you're adding, because sum means you're adding a whole number n's to a negative 7, so the result should not be greater. So it says no greater. Okay, the result is no greater, so no greater than negative 35. So we are going to represent this with the variable n, okay, added with a negative 7. So when you're adding negative 7 is the same thing as minus 7, okay, because plus negative 7, okay, another way of writing that one down is n minus 7. So this is how you simplify it down. Okay, simplify down to n minus 7. So when you say no greater than, so that means it should not be greater than negative 35. So this one right here, when you're adding those two numbers, it is smaller than or equal to negative 35. So now to find the greatest value of n that makes this true, okay, we are going to solve our the value of n. Okay, so that means we are going to take the opposite of negative 7 by adding 7 on both sides. Okay, so minus 7 plus 7 on the left side cancels out. Okay, that makes n by itself on the left side. Copy the symbol, less than or equal to, and then we're taking negative 35 plus 7, that is negative 28. Alright, so that's our solution of the inequality. So the greatest value of n that makes the statement true is any whole number less than or equal to negative 28. Alright, so for number 8, for number 7, for some reason I was looking at this slide number 8, but we are still on number 7. Alright, so we have a graph of an inequality, and we are going to write an inequality that represents the graph. So in this case, okay, your x value right here, okay, could be any number, okay, that is smaller than 2, because your shading, okay, of the graph is to the left, and if you look at it, all of the left numbers, okay, all of the numbers to the left of 2 are smaller. So this numbers right here is represented by our variable x, okay, and since they are smaller than 2, then it has to be less than, and we are not going to put the underline at the bottom since the dot right here is open, so that means 2 is not included in the solution. So it would be x less than 2. So x right here represents this number right here that is less than 2. So if you're going to take this number, -5, that would still hold the inequality true, okay, based on the graph. Alright, so for number 8, so we have here an inequality y less than -7.34. So if you look at here, okay, is y equal to -7.35 a solution, and if you're looking all the options, they're all negative numbers. Now the easier way to think about this is that number is bigger in the negative side, the smaller the number it is. So that's just what you need to think. It's the opposite of positive numbers. Alright, what we're going to do here is we are going to replace the value of our y into our inequality, in our given inequality, and compare if that makes a solution of the inequality, meaning if that makes the inequality true or not. So let's say if we take y, replace the y with -7.35. Okay, let's see here, -7.35, okay, less than -7.34. So is that a solution? Would that makes the inequality true? Well, -7.35 is bigger than -7.34, and the bigger the number it is in the negative side, okay, the smaller it is. So that makes the solution true. So yes. Okay, for number 2, now we are going to replace that y with -7.32. Is that less than -7.34? Well, this one, again, we're talking about smaller negative numbers. The bigger the number it is, the smaller. But if you're looking at here, then the bigger number is -7.35, and it says it's greater, but it's the opposite of what we're supposed to be thinking, right? So it should be less than, because this is a bigger number. Okay, so it is no. That's not a solution. So the third one is -7.34 less than -7.34. Well, they are equal to each other. So again, that is not a solution. And then the fourth one is -7.3. So that means there's a 0 there, less than -7.34. Again, the bigger the number it is, the smaller it is. But it says right here, -7.30 is smaller than -7.34. So that makes a no. Alright, we're getting closer to our last problem. So we are on number 9. So we are going to solve what is the value of d. Now if you notice, your variable d is both on the left side and the right side of the inequality. Now just like your when you're solving for an equation, you're going to collect all the variables to one side of the equation. So same as the inequality. So what I would do here is I'm going to collect all my variables to the left side of the inequality. So that means if this is my inequality, I'm going to take that negative d and put it to the left side by using the inverse operation. So the opposite of negative d is adding d. So what makes sense? That makes sense because then that would cancel out. But what you do on one side, you have to do it on the other side. So I'm going to add d on the other side of the inequality as well. So this cancels out, okay? Now take note, This is your inequality right here. So what's left on your right side, or what remains on the right side of the inequality, is just the 3, okay? And okay, I'm just gonna put a line there. And then what happens here is that you have the 3, okay, and then you have two D's, okay, plus one D, okay, plus another D. That makes it plus 2D. Now we wanted to get D by itself by getting rid of that positive 3. So the inverse of positive 3 is negative 3. And what you do on one side again, do it on the other side. So this cancels out. So bring down your 2D. Now remember, you still have that inequality symbol right there. And on the right side, you have 3 minus 3 is 0. Now to get D by itself, okay, since we have 2 times D, the inverse of that is dividing 2 on both sides. So your D right here is less than 0. So the solution for this inequality is D less than 0. Alright, we are now on the last one of the inequality. Alright, so what I'm going to do here, since there's only one variable to the right side and the left side doesn't have a variable, so for now let's just keep that x to the right side of the equation, okay? So we're going to get rid of that positive 10. So I'll just put a line there because I wanted to make sure that that's where my inequality here. It's kind of like your equation, but it's just an inequality. You have the right side of the inequality and the left side of the inequality. So I'm going to get rid of that positive 10 by subtracting 10 on both sides. So this cancels out, okay? What's left on the right side would be just negative 8x. So I'm going to bring that negative down right here, negative 8x, and what's left, and negative 6 plus negative 10 is negative 16. Okay, remember, when two negatives, when you're adding up two negatives, you add and keep the same sign. Alright, now you still have that inequality symbol right here. Now you have on the right side is your x, and we wanted to get the x by itself, and the x is multiplied by negative 8. Now when we are going to isolate that x, we use the inverse operation by dividing negative 8, not just 8 but negative 8. So what you do on one side, do it on the other side. Now here is the catch. So every time you divide or multiply a negative number, this symbol flips. So instead of going that direction, it flips on the other side. So that's only when you are dividing it or multiplying by a negative number. Okay, negative number. And we have a negative number there. So x right here, okay, so you have, let's do the math here on the left side. Negative 16 divided by negative 8 is positive 2. Now if you notice, okay, your x right here should be bigger than 2. So we can rewrite this because I like to put my variable on the left side. So I like to put my variable on the left side, and it's still bigger, so the alligator still eats the variable x too. So that would be my answer. So if you do have questions and you're still confused, please send me an email. This should be, if you do all of this review and you do it all correct, so you should be able to get your Unit 1 test done. So again, this unit review is unlimited. Take it as many times as you want until you get at least a 60%, and Once you get to at least a 60% of this Unit 1 review, then you're ready to take your Unit 1 test. All right, so send me an email if you still are confused and you need help. All right, see ya. Bye.